Okay, I want you to pause the video now and answer the question on the screen. Identify inscribed angles and the arcs they intercept in the figure below. So if you pause it after a couple seconds, I will show you the answers. Okay, so we have angle BAC, which intercepts arc BC. Angle FAC intercepts arc FC. Inscribed angle BAF intercepting arc BF. Angle GDC intercepting minor arc GC. Angle GDB intercepting arc GB. Angle BDC intercepting arc BC. I think I might have said that already. And there's also GDC intercepting arc GC. Now if you said this arc this angle BEC intercepts arc BC, that's correct, but it's not an inscribed angle. This right here is a central angle. Okay, now here's a quick proof on why inscribed angles like this angle ABC always going to be half the measure of the arcs they intercept. Okay, so let's start with this angle X here, this central angle ADC. Alright, if that's going to be X degrees, then this arc AC also has to be X degrees. Alright, this angle here BDA has to be 180 minus X because they're a linear pair. So like 180 minus X plus X would give us 180 degrees. Now this triangle here, ADB, is an isosceles triangle. That's because AD and BD are congruent because they're both radiuses. So these two angles here have to be equal to each other. So to find the measure of this angle, in particular B, we're going to take 180 degrees, which represents all three angles of this triangle, subtract the vertex angle, 180 minus X, alright, and then divide that whole thing by 2, because if you take 180 degrees and subtract this angle, you'll be left with these two base angles, and they have to be equal, so we're going to divide it by 2. So that simplifies to 180 minus 180 plus X over 2. 180 minus 180 cancels out, and we get X over 2 is the measure of this angle, which is exactly half of this arc, X degrees. So it's a little proof on why inscribed angles are always half the measures of the arc. And if you did that proof the other way, started out saying, alright, this angle is like Y degrees, then you could prove that this angle is 2Y degrees. So if you got a second, why don't you pause the video and try to do that. Okay, so as I just mentioned, as we just proved, the most important property of an inscribed angle is that it's half the measure of the arc. So why don't you try these problems, pause the video, and in a couple seconds, when you unpause it, the answers will be there, and I can go over each one. Okay, here are the answers. We start with A. Well, if this angle is 130, then this arc is going to be 130. So A has to be half of that, 65. Another one, E here. So this whole arc is a semicircle, so it's 180 degrees. So if you subtract 96 from it, you get that angle right there is 84. So this angle is going to be half of that. Similarly, if this arc is 20, you can assume that this remaining part here, D, is going to be 140. Sorry, I lied. If this angle is 20, then this arc is 40. So this remaining arc has to be 140, because the arc is going to be double the inscribed angle measure. Okay, what's the sum of A, B, C, D, and E? Well, it's going to be 180, because if A is an inscribed angle, right, it intercepts that arc right there. And then we have C, which is an inscribed angle. That arc right there, it intercepts. Then we have B is an inscribed angle. Intercepts that arc right there. D is an inscribed angle, and it intercepts that arc. And then E is also an inscribed angle, and it intercepts this arc. If you notice, the 5 arcs in red, orange, yellow, green, and blue, they make a full circle. And all the inscribed angles, so that's 360. And then all those angles are going to be half the measures of their arcs, so if the arcs add up to 360, then all the angles have to add up to half of that 180.